So now we have to discuss the important concept, that is nothing but electric field lines. So electric field lines is nothing but these are the imaginary lines or smooth curves in which a unit positive charge moves or tends to move. So for an example, so let us consider a charge plus q here. Now this is the charge plus q. You are bringing one more charge from infinite to this distance at a distance of r. Let this charge be q. Then the force is experienced by this charge. It is given by F is equal to, it is E into Q by the definition of electric field. Now we will say that the electric field due to this plus Q charge is directed in this direction. This representation is called as, it is electric field lines. So in which a unit positive charge moves or tends to move is called as electric field lines. There are certain properties regarding these electric field lines are, so if there are two charges plus q and minus q, they are separated by the certain distance r, then electric field lines starts from this positive charge and they will end at this negative charge. Like this we will show. So like this. So they are going outside and here they will come inside like this. If there are two positive charges, this is plus q plus q. You all know that like charges repel each other, unlike charges attract each other. And the charge is, the electric field lines start from this charge, no? So therefore electric field lines are like this. So they are going like this. Here also they are going like this. But they will not intersect at any point. So another properties of electric field lines is nothing but they will not intersect at any point. So that is nothing but they will not cross over. So like this, these are all some properties. And if they are meeting at the charge conductor, if it is a conductor, charge conductor, electric field lines always meet at the conductor at right angles, that is nothing but 90 degree. So other some properties you have studied. So the definition of the electric field lines is nothing but these are the imaginary lines or smooth curves in which a unit positive charge moves or tends to move. Okay. So next concept is nothing but electric dipole. So electric dipole is nothing but, so if you are placing here plus q charge and the identical charge but with opposite in sign, that is plus q and minus q, you are placing at a certain distance. So this forms one system. This system is called as electric dipole. That is nothing but a pair of equal and opposite charges separated by the small distance. So here we are writing this distance as 2a. Therefore it is forms one system. That is called as electric dipole. So definition of the electric dipole says that a pair of equal and opposite charges separated by the small distance. If it is one charge, this is another charge. If it is plus q, then it is minus q, and the separation distance between them is 2a, and this system is called as electric dipole. Then one more definition, electric dipole moment. The product of magnitude of either charge. So magnitude of either charge is nothing but charge is q and the separation distance between them. Separation distance is nothing but it is 2a. When you product this q into 2a, this gives one physical quantity. This physical quantity is nothing but electric dipole. It is represented like this P. Okay. So now we have to write is SI unit. SI unit can be written as, you know, the SI unit for this q is nothing but it will be coulomb and the distance SI unit is, it is meter. Therefore SI unit of this dipole moment is coulomb meter. One more unit is there, that is called as d by. So but we are going to study only this unit, that is coulomb meter is the SI unit for this electric dipole. So understood? The electric dipole moment is nothing but it is the product of magnitude of either charge and the separation between them. Electric dipole is nothing but it is the pair of equal charges, equal and opposite charges separated by the small distance. This will be the system. The magnitude of this system is nothing but it will be the electric dipole moment. Okay, so next is nothing but by using this electric dipole we can find out the electric field at any point. So we are considering the 2 points. The 2 points are nothing but the axial point and the equatorial point. So if we are considering a dipole, this will be the dipole. So here if you are considering one point, let it be P. So from this dipole, this point is here, means this axis, the passing through this dipole is called as, axial line of the dipole. We will call it as a axial line. The line passing from this dipole axis is called as axial line of the dipole. A line which is perpendicular to the dipole axis. So it is dipole. This line is called as perpendicular. So perpendicular line. This perpendicular line is called as equatorial line of the dipole. Now we have to study, or we have to derive the expression for electric field on the axial line and on the equatorial plane. So now we will discuss how it will be possible to derive the expression for electric field due to a dipole at a point on the axial line. Let us consider a dipole. First you draw the dipole, that is nothing but plus q and minus q charges. That is 1, this will be the minus q, and here let us consider the charge as it will be plus q. So length of the dipole is nothing but it is 2a is the length of the dipole. Let us consider one point P. Point P at a distance r, from the midpoint O. So let it be AB is the dipole. The midpoint of the dipole is nothing but it is O. Distance between this point P from the O is nothing but it will be the R. Now we have to find the electric field at this point. What is the electric field due to this point? By generalizing this diagram, we will get this diagram as like this. So AB is the dipole, minus Q plus Q. Distance between the two charges nothing but it will be the 2a. O is the midpoint. Let us consider the point P at a distance r from O. Electric field due to this minus Q charge is given by, it is E1. We know that electric field lines for a negative charge, they will start at infinity and end at charge. Therefore the arrow mark is like this. So it is converging at this point. And electric field at P due to charge plus Q is nothing but it is going outward because it is a positive charge. Electric field line starts from positive charge and end at negative charge. Therefore it is like this. The resultant is nothing but E is equal to E2 minus E1. So we will discuss here. So here see that electric field general definition is nothing but E is equal to 1 divided by 4 pi epsilon naught. It is Q divided by it is D square if the separation distance is D. Now here you are considering the charge as minus Q and you are going to find out the electric field at P. Therefore the electric field will be 1 divided by 4 pi epsilon naught. It is Q, taking only the magnitude, Q divided by it will be the AP square, right? It is AP square. But what is the value of AP? AP is nothing but it is sum of AO plus OP. AO is nothing but it is A. Here is also it is A. So therefore you can write it as 1 divided by 4 pi epsilon naught. It is Q divided by it is what is R plus A whole square. This distance is A, this distance is R. Therefore it is R plus A whole square. Along this direction, along it is PA. Along it is PA. Similarly, you can write it as E2. E2 is nothing but 1 divided by 4 pi epsilon naught. It is Q divided by the distance is nothing but it is BP square. So therefore you can write it as 1 divided by 4 pi epsilon naught. Q divided by BP is nothing but it is OP minus OB. Therefore it is nothing but R minus A whole square. On substituting this, we can see here this R minus A denominator term in this E2 is smaller compared to this term. Therefore, clearly E2 is greater than E1. E2 is greater than E1. Therefore, the resultant electric field will be E is equal to E2 minus E1. So therefore you are getting it as 1 divided by 4 pi epsilon naught. It is common. So and Q is also common. You are left with 1 divided by R minus A whole square minus 1 divided by R plus A whole square. On solving, and you will get the equation as E is equal to 1 divided by 4 pi epsilon naught 2 PR divided by R square minus A square whole square. So this is the expression for electric field. In detail you have studied in your regular classes. This is only the rough, only revision classes all we have given. And the special case also we are going to study here. If the R is much greater than A, the distance of the point P is much greater than, so then it will be reduces to E is equal to 1 divided by 4 pi epsilon naught. It will be 2p divided by A square is neglected, then you are getting R to the power of 4. 1 R you are going to cancel, then you are getting the equation as E is equal to 1 divided by 4 pi epsilon naught 2p divided by, it will be R cube. This is the electric field from the dipole at a short place. Okay, thank you.